Folks, I've been looking forward to this. This is section S, my favorite section from IXL. As you can see, there are 27 sections of linear functions, and I think I'm just going to do them all in order. I've been looking forward to doing this one for a long time. I decided to save it up. So I'm going to start with S1, the very first one. I have not done it yet. I haven't previewed it. I don't know exactly what they're going to look for, but here we go. The graph shows a function. Is the function linear or nonlinear? Well, it looks like a line to me. Let's move over here so I can see you. That doesn't look like a line. This is actually what I call a sideways cubic. It's the reverse. It's actually a cube root function. And this one is linear. And the way you can tell is that anytime you have f of x in f of x notation, this is in what's called function notation, and you have a single variable, usually it's always x, to the first power, it is linear. The only real exception to this is when you have f of x equals a constant, like 5. This one is called a constant function, which is also linear, but anything that has a variable to the first power. Now, you won't always see that first power written. Sometimes it's just going to look like that. But there is an assumed 1 to that x when the x is written like that. Anyway, of course, this is linear. This one is nonlinear again because it's not in a line. This happens to be something, well, I could write the equation and everything, but it's a cube root function, but it's nonlinear. This is a square root function, and if I were to graph it, I could graph it. It would be sideways. It would look something like this, but we know that it's nonlinear. It doesn't form a line because it's to the 1/2 power. This one looks linear to me. This one is linear. It has a single x value in it. This is nonlinear. Now this time the 8x is an inverse graph. This one is going to look something like this and like this. These are definitely nonlinear. When the x is in the denominator, you're going to get a graph that looks something like this. This is a reciprocal type graph. It's nonlinear. Now this one has a fraction in it, but f of x is equal to 9/2x. That x is to the first power, which is linear. This one is nonlinear. This one is a negative exponential graph, and it is definitely nonlinear. Oh, interesting. Is the function linear or nonlinear? Well, this is actually what would normally be called a step function, but the points are linear. What's happening is that we have that we're only looking at whole numbers, but I'm assuming that they meant for it to be linear because it actually is y equals 1/2 x minus, this is the equation, y equals negative 1/2 x, it looks like. Oh, maybe it isn't. Maybe it's 1/3. Oh, it's a little off, darn. Yeah, it doesn't quite work. Anyway, it's about negative 1/2 x minus 1.5, more or less. This is just about correct. So I'm going to say it's linear. And linear. And exponential. And That's a cubic graph. This one would look something like y equals x cubed. Now, it's been compressed and it's been moved to a new location, so it's going to have a fraction in front of it, like maybe 1/8, and then it's been moved to a new location, but it's definitely nonlinear. This one, a lot of people are going to get confused because that 10 is in the denominator and that's going to freak them out. But keep in mind that this says h of x is equal to 9/10 plus 1/10 x. And that is definitely a line. In fact, if you were to graph it, it would go something like this. It would be a very shallow, it's not a very steep line. It only has a 1/10 slope. It's linear. This one looks more or less linear. It looks good enough. This one is a cubic again. This one is linear. And what do we got here? Oh, this is definitely non-linear. Even though there's just that little x there, that x is in the exponent, and this is an exponential. So this thing, if you were to graph it, would look something like -7/4 is about here, and it would look something like this. Oh, actually, it would be here. Sorry. It would look something like this. If you were to graph it, that's definitely nonlinear. This one is linear. Another way to write this would be h of x is equal to 8/5, which is just a number. It's 1.6 minus 1/2 x. So this is going to be going somewhere about here, and it's going to look something like that. It's actually not quite that steep, but it's pretty close. This one is definitely nonlinear. That x to the 6th power looks like it looks a bit parabolic, but it's really, really, really steep. So it's going to go through negative 10/9 plus 2/9 at 0. Anyway, it's going to look something like this. Really, really, really steep. It's going to be even steeper than that. It's going to be really steep. It's definitely nonlinear. This one is linear. It's actually 9/4, which is 2.25, which is going to go like right there. Everything costs $2.25. That would be a constant function with a slope of 0. This one is a parabola because it has an x squared in it. That is called a quadratic function, and it is nonlinear. This one is linear because it has an x to the 1st power in it, even though you don't see that 1 there. And I'm sure you're getting tired. We'll get done here. Now this one has a square root of x in it, which is nonlinear. Square root of x looks like this, so it's going to be some variation of that. Sorry, it's not a very good graph. There we go. It's going to look like something like a sideways parabola. Anyway, it's nonlinear. And this one is nonlinear. This is another case of having that x in the denominator. So it's some variation of this. It's been moved a bit. It's been moved up or down a bit, and it's a bit steeper than normal, but it's nonlinear. This one is a constant function, which is linear. And we have one last one, and it is linear. The x is in the numerator. It is linear. And I hope you guys got that. And we're all done. So pretty quick. And have a nice day. And I'll see you back. Can't wait to finish these.